Alright guys, this is motion notes part 3, acceleration, and we're going to do some acceleration problems. The acceleration describes the rate of change with velocity over a period of time. So it's velocity over time. Okay, so that's the equation for that. Here it is. Acceleration is your change in velocity, or velocity final minus velocity initial, divided by the time period that it happened in. Okay. Acceleration happens when an object, you need to know that it happens three ways. Speeds up, slows down, so that's deceleration, right? Deceleration. Or it changes directions. That's a really fancy way of just saying turns. Okay, speeding up is accelerating. That's what we call acceleration. Slowing down is accelerating in the negative direction, or deceleration. Deceleration. Changing direction will also change your velocity. Acceleration is what type of quantity? Vector, scalar. Well, if we care about the direction, guess what? It better be vector, right? Vector. Right, so let's go ahead and put that one in there. Okay, so it's another vector quantity that we need to know about. So let's review what scalar and vector means. Okay, a scalar quantity is a simple measurement. A vector quantity has direction. So let's place these four here, right spots, 4 or 5 here. So vector is going to call, well, the first vector quantity we learned about was displacement, right? And then we learned about velocity. And of course now we have acceleration, right? Acceleration. Acceleration. So those are the three vector quantities we learned about in this chapter. Alright, now scalar, the first scalar one we learned about was distance. We just add up the total length of the path, no matter if we turn or not. And of course, speed, like your speedometer, you never care about the direction in there. So these are your scalar and vector quantities for the chapter. Make sure you know those. Okay, now let's look at our Ranger lab, kind of. Okay, so look at here. Automobile at rest. So look, our distance is not changing over time. Okay, remember that time is the independent variable. Now, if I'm moving at a constant velocity, notice that this is also a constant velocity, right? Constant velocity of 0 meters per second, right? Here, this is a constant velocity here, so you actually do have a slope that's not equal to 0. If it's a positive slope, guess what? My velocity is positive, right? Okay, now, if I have constant acceleration, remember we did this in the Ranger lab, this is when you're going to have a curve on the graph, okay? A curve on the graph. So like, see how it's like a curve? It's not a straight line, but it's a curve. This is evidence of acceleration, okay? This is evidence of acceleration. It's very important that you know that. Anytime you see like a curve, it's acceleration. Down here. Okay, now velocity is at 0. That means we are not moving. Okay, so that would be like this, like your speedometer is at the 0 the entire time, no matter what. So if it's at 0, where's 0 on here? And there we go. There's 0. So you're going to have a constant velocity of 0 along this line with a constant value. Okay, now, if we have a constant velocity on a velocity time graph, notice that these are velocity time graphs, right? So let's say I had a constant velocity of like 10 or something, right? So that would look like this on my speedometer, right? There'd be like a 10 here. Okay. So if I were not at 0, but I was at 10 meters per second constantly, well, I'd go up to the graph where velocity is at, where 10 is at, and I would draw a straight line because it has to remain 10 the entire time. Okay, now if I am accelerating on a velocity time graph, it should look like this, right? So look at my speedometer. So velocity is increasing, right? So I need to have a slope that is positive for a velocity time graph. So this upward slope is showing the exact same thing that I showed with the needle moving upward, right? Okay, now, down here to an acceleration time graph. Notice that time is the independent variable the entire time, right? It's the thing that's happening regardless. Now, if I don't have any acceleration, well, what does not having any mean? It means 0, right? So that means I need a constant value of 0 acceleration. Okay. Constant velocity, there's no change in velocity, so that means I have no acceleration. It's going to stay on the 0 line. Now, if I have a constant acceleration, constant just means a horizontal line. So anything above or below 0 would be fine. accelerating in the negative direction, I would need a constant acceleration down here. Now let's do some acceleration problems real quick. All right. Let's underline, after traveling for 6 seconds, so underline that's t, we're going to reach the speed of 10 meters per second. This is our velocity. Now, we're going to assume that if we started running, we started at what speed? Well, we have to assume that our velocity initial was 0, okay? So we're going to assume it's at rest, okay? Okay, so this would be our velocity final. That means our velocity initial is 0. We're looking for the acceleration. Acceleration equals, make sure to do this part right. All right, so let's go down to the next one. Cyclist accelerates at a rate 7 meters per second squared. So that's going to be acceleration. How long will it take? That's a what type of question? Time question equals question mark. To reach a speed of 18 meters per second. So that's our velocity final equals what? Our velocity final. Okay. So again, if we are starting from rest, what's our velocity initial? Starting from rest, that's going to be 0 meters per second, right? Okay, skateboarder traveling at 7 meters per second. So this is our velocity initial. Rolls to a stop. So what's our velocity final if we're stopping? 0 at the top of a ramp in 3 seconds. So that's time. What is the acceleration? So acceleration equals question mark, right? Okay. So you would write these things. You would take these values and write them in your G for given. Okay, what is our unknown? Our unknown in the first one is the acceleration. Our unknown in the second problem is how long will it take, so that's time equals. And our unknown in the third problem is acceleration equals. Okay. Now, what did we say our equation was earlier? Our equation is going to be acceleration equals v final minus v initial over time, or our other equation is going to be, if we flip the top and the bottom, we can solve for time. So we have time equals v final minus v initial over acceleration. So these are our two equations, and you'll have these given to you. Okay. So let's see, we're looking for acceleration, so we're going to use the first equation over here. So acceleration equals v final minus v initial, so your last velocity minus your first velocity, and then divided by your time. Okay, so let's go ahead and substitute that. That's going to be, let's see, what's our velocity final? 10 meters per second minus our initial is 0, right? And we're going to divide by our time, 6 seconds. Okay. And that comes out to, so I have a calculator here. Here we go. All right. 10 divided by 6, so we get 1.67. So that is our answer, 1.67, and acceleration is always measured in meters per second squared. Okay, meters per second squared. Good. Okay, next. Okay, so we're solving for time in this one. What was the time? So our equation for time was t equals v final minus v initial over a. And time equals v final minus v initial divided by our acceleration. Let's go ahead and plug that in. V final was 18 minus our v initial because we're starting at rest. And then divide by our acceleration of 7. So let's see what that is. 18 divided by 7, 2.57 is our 2.57, and it's like, I don't remember what I was solving for. Well, what was the question? Time, right? So this should be in seconds, right? Okay, last one here. All right, we're solving for acceleration, so what equation was that? A equals v final minus v initial of time. All right, let's see. A equals v final minus v initial over our time. Now let's do the substitute or plug in. Okay, so our v final is 0. Wow, that's interesting, right? Minus 7. That's our v initial. Notice I'm making sure to plug them in the right order. And our time was 3 seconds. All right, so let's see what happens with 0 minus 7. If we weren't sure, we can do it in the calculator. 0 minus 7, negative 7. Okay, divided by 3. Negative 2.3 repeating. Negative 2.33 repeating, right? And what's the unit for acceleration? That's meters per second squared, right? So this means I was slowing down or accelerating in the negative direction. So be very, very careful with your sign and make sure that you always plug in the correct value for V final, right? Just because you don't always just put in the bigger number because it's first, right? You have to follow the format. All right, good luck.